Hi there. Thanks for being with us today. My name is Carmina. I'll be your host for today's presentation titled Simulate More, Wait Less, Cloud HPC for PathWave ADS 2021 is here. On the line with us today are Stephen Slater, Dan Schwartz from Keysight, and our guests from Nimbix, Adil Noor and Mike Schutz. And to start us off, Stephen Slater, welcome. You now have the floor.
Thank you very much, Carmina, and welcome to everybody for joining us today. So I'm a product manager with Keysight. I'm very pleased to be presenting here with Nimbix today to talk about new innovations in cloud HPC. What is our commitment to you by the end of this session? We want to make sure that you have enough information to be able to answer these 4 questions. So what is HPC and why is it important to me? How can HPC be deployed best for my needs? How does HPC actually work inside of PathWave ADS? And how can I access Nimbix for scalable HPC? So we've got a very busy agenda for you, split across 4 different speakers. I'm going to take us through the very first session. So let's get started with why do we need high-performance computing? Well, because designs are becoming more complex. And I'm going to show you 3 individual types of designers and their specific problems, and talk about how their electromagnetic simulation is becoming more time-consuming. So here's an antenna designer. The antenna designer needs to design antenna arrays, and in this case, they're simulating for multiple frequency bands and trying to calculate, a very accurate beam steering. So why is this problem difficult to solve with electromagnetic simulation? It's because there's hundreds of array elements, and pushing up to very high frequencies. This particular design is a millimeter wave design, so we're talking more than 100 gigahertz. So that's going to create an EM problem that has a lot of tetrahedrons to solve. Next, we've got a mimic module designer. And here, the key thing is that the job's not getting easier. There's many more different modes of operation and more frequency bands they need to cover. And also, they need to care about the interplay of the package together with the interconnects like the bond wires and the final IC layout. So when we try to do electromagnetic simulation of these designs, you've got electrically large features together with electrically small features. And again, that can make for a rather sizable simulation. And then finally, what about a signal integrity engineer? You've got PCBs that are very large with many layers, and there can be hundreds of signal nets that are very high speed. So we want to be able to simulate groups of signals at once, and we want to be able to capture the crosstalk accurately between them. But many signal nets plus high frequency means that the simulation problem can be rather large. So we've got 3 different designers, but they all have the same problem, which is there's just not enough time to simulate everything that I want. So, no doubt your own design workflow or design process may be a little different to what I've depicted here, but hopefully you resonate with the idea that there's design iterations, and at each point we have to run another EM simulation and another EM simulation. And right at the end, we've got an expected design sign-off at some fixed target date. So what if we can compress the time that it takes to simulate so that we actually have more time to simulate more, verify more, and worry less? That seems like a very good thing to do. So the outcome of that is you're going to reduce risk, and you're going to enjoy higher confidence at design sign-off, and that's going to be excellent for everybody. So let's jump to an example, and this is a flagship example for us to show you the true power of cloud HPC. So this is a Xilinx evaluation board. We want to tackle the entire DDR data bus. So there's 88 signal nets in total. It's a 16-layer PCB. We've got 44 frequency points that we need to solve for, and that leads to 176 EM ports on this particular design. And essentially you're going to get an S parameter that's S176 by 176. That's a huge amount of data. We're going to have a very large S parameter file out of this. The solution that we used is SI Pro. It's a dedicated EM solver inside of PathWave ADS. We used these brand new HPC EM droplet licenses, and then I used hardware on Nimbix Cloud HPC platform. And I was able to get the single sim time, which was nearly 15 hours, able to use the eight times machine and get that simulation time down to 2.5 hours, reducing the extraction by 83% in total. Okay, but we are getting ahead of ourselves because I haven't really stopped to explain yet what is HPC. So HPC, high performance computing, it's the use of parallel processing algorithms and systems. And I think the systems part is most important because what we're trying to do is make use of different compute hardware that we've got and be able to aggregate it or pool it together to be able to solve complex simulation problems. So what it means really for us is if I've got one particular job I want to solve, is there any possible way I can solve that across 4 machines or 8 machines and get to a much faster simulation time out of it? So let's talk about different HPC deployments. You might have access to already is a single large machine. You might have access to an on-premise cluster. You might have access to your company's own private cloud set up for EDA simulation. And then if it's very advanced, you might have access to a hybrid cloud where the hybrid cloud is using the on-premise cluster, but then for peak needs, you start to use cloud resources. If you don't have access to these things today, then it shouldn't be lost on you that the system implementation complexity increases very significantly as we get down towards the bottom. Some of the things that you need to think about are things like user authentication, a shared file system, okay? How the application ADS is plumbed to be able to access the license server and be able to access the individual machines, and how it's able to access the job schedulers and setting up and maintaining the job schedulers. So, it can be quite a daunting task for an organization that doesn't have these set up already to go about setting up for the first time. But luckily, it doesn't need to be hard because in introducing our partners today, Nimbix, that we have a very easy access way to be able to have scalable hardware resources in the cloud with a single turnkey approach. Some of the benefits of using a company like Nimbix is that we as Keysight publish our products directly to the Nimbix platform. We make sure all the supplemental software is already configured and set up. It's QA tested. And you get access to the scalable hardware resources, and it's a pay-per-use for the hardware that you need. The next thing is that having access to Nimbix is not the only thing that we've done. We've also created we call it Design Cloud Sim Service, and it's a very efficient and very nice user experience where if you install the Sim Service on the hardware that you're using, so whether it's on Nimbix, it already comes pre-configured, or it could be on a server, a cluster, or a cloud. Now what it means is that you can have your local machine with ADS running on your local machine, and then you just press simulate and it will submit the job directly to the sim service. And then now the job will be running on that hardware. The beauty of this is that now your actual local machine is decoupled from the simulation. I can shut down my PC, I can shut down ADS, it doesn't matter, the job is still running. And I can always check on how the job's going by looking at a web service, which Dan is going to show you a little bit later on. The next thing is that the moment I start up ADS again, it will reconnect to the sim service, check if anything's ready, if anything's finished and ready to be downloaded, and then it will download those files back to my local machine. One of the real significant benefits of this is our workspaces can be gigabytes in size, but the simulation files that we need for that very specific simulation may only be tens of megabytes or maybe 100 megabytes maximum. So by using Design Cloud, we're not transferring a giant workspace all the way over to the server to run it there. You actually just press simulate and the software sends only the files that it needs. Okay, so I'd like to pass now over to Dan. He's going to take you into a little bit more detail about how we use these parallel processing with the EM solvers and then through a couple of case studies. So take it away, Dan.
Okay, thanks so much, Stephen. My name is Dan Schwartz. I'm an applications engineer at Keysight Technologies. And the first thing I'd like to do is clear up a little bit of terminology you may not be familiar with. You hear ADS, SI Pro, RF Pro, Momentum, FEM. What's it all mean? ADS and EM Pro are our flagship simulation products. Within ADS there resides some specialized EM solvers, our Pro tools. So PI Pro, SI Pro, PE Pro. So for instance, SI Pro is built from the ground up to solve really advanced high-speed digital signal integrity applications. ADS RF Pro and EM Pro contain generalized RF microwave solvers used for applications like antennas, integrated circuits, or complex modules, as we're going to be looking at. So there's two different solver technologies that are implemented. They're called Momentum and FEM. So it's easier to explain this by looking at this slide. Right? What's the difference between Momentum and FEM? This is a collaborating customer, Menlo Microwave. They've designed these MEMS single-pole 4-throw switches, and it's mounted onto a test fixture. Momentum, or method of moments, is a planar 3D EM simulator. So on the lower left, you see ADS layout of the single pole 4-throw switch. It's realized with a Z-extruded stacked metallization layers. So metal on top of substrate on top of metal. That's what we mean by a planar circuit. So Momentum is ideal for integrated circuits, PCBs, antennas, anything planar. Now, if you can imagine, we take this chip and we flip it and we mount it onto the test fixture as is shown on the right. The finite dimensions of the chips, as well as the integration of the 3D connectors, makes this an arbitrary 3D structure. So we can no longer solve this with a Momentum solver. We need to use what's called FEM, or finite element. So finite element is an arbitrary 3D EM solver for things like modules, antennas, and other applications like that. At a very high level, both Momentum and FEM, right, turn the physical structure into a bunch of tetrahedrons. Those tetrahedrons are solved, have their fields solved over a specified frequency range. The problem, as shown in this chart, is that the solver is broken down into different steps depending on which technology you're using. Our HPC solutions, right, use either multi-threading or parallelization over these steps in order to achieve faster simulation times. And the multi-threading actually comes free. There's no additional licenses for you to buy. So if you have a local machine and you have a lot of cores on that machine, you can utilize all those cores at no additional cost. The most amount of time for the entire solve is really spent on the frequency sweeps. So as we show here, let's say we have an RF Pro FEM simulation, and we want to solve this over 41 frequency points. If we can parse this out over 4 different nodes at approximately 10 frequency points per node, we're going to be maximizing our simulation efficiency. So to demonstrate this, I have two case studies that I'd like to show you. The first case study is a Keysight Labs design. It's a complex LO converter module that's in this analyzer shown on the lower right. The PCB is a 16-layer complex mixed signal board integrated with some Keysight package devices with like a clamshell housing, gasketing material, and connectors. So it's a very classic microwave type problem to solve. We're looking for cavity resonances, we're looking for circuit responses. It's a very wide band, so we're running this from DC to 55 gigahertz over 56 frequency points. The solution that we're going to use is PathWave ADS with also with EM Pro. Now, this case study, we used an internal Keysight high-performance cluster that we have in Ghent, Belgium. We only have 4 nodes on that cluster, so we're going to parallelize this out to 4 parallel frequency sweeps. What the design looks like is, on the top left, you see an EM Pro cut view of the Keysight devices, the Keysight integrated circuit devices that are flipped, mounted onto solder balls, and then not shown here is the QFN molded packages that they're then packaged into. Those are then placed onto the 16-layer board that's shown in the ADS layout view in the middle here. We just have the top layer turned on for clarity. So once the devices are mounted, that whole ADS assembly is now exported back into EM Pro, which is shown on the lower right, where we can integrate in all the different 3D components that are in design. So connector, gasketing material, absorbing material, and shell housings. I'd like to show this to you live, so let me share my screen with you. Okay, screen.
Yep, we can see it now, Dan.
Okay, thank you, Stephen. So we're looking at EM Pro, and you can see the entire design has been, the entire board design has been brought in from ADS, so we see the import. It's been all designed with all the other features that I just described, so connector, gasketing, some shielding material, as well as some microwave absorber that's just turned off for clarity here. So in order to launch this now into a high-performance cluster environment, I'm going to open up my simulation options here. You can see I'm running this from 0 to 55 gigahertz over 56 frequency points. And if I go into my resources tab here, all I need to do to parse this off to the cluster is under this host field here, I need to point to the web address of the cluster. So right now I'm pointing to the simulation service that we have running in our Ghent, Belgium facility. I'm not hooked up to our company's VPN network, so you can see that there's a little error message here that says it's failed to connect to the simulation service. If I went on VPN, this would turn green. And at that point, all I need to do is specify the number of parallel frequency points and set the simulation off running. As Stephen mentioned, right, at that point, if I want, I can shut EM Pro down, wait for the simulation to complete, come back and download all the simulation results. So we've benchmarked this, and okay, you should be back on slides now, right? Are we back on the slides?
You are, Dan, yes.
Okay, great, thank you. Okay, so we've benchmarked this, and we've run 3 different benchmarks. The first benchmark is on my local high-performance engineering laptop. It's a 6-core i9 machine. So in this machine, it took 3 hours, 21 minutes. And then if I ran it on our internal Keysight single node machine, so as I now put more cores into the problem, you see the simulation time reduced to 1 hour, 30 minutes. And then parsing this out over 4 different parallel nodes brought it down to 42 minutes for a total reduction in simulation time of 79%. Okay, for case study number 2, this is a multi-technology module design. It's actually part of a workshop that we've put together. It's available to anyone that's interested in it. Just let us know after the webinar. We can get that off to you. It's a module that integrates a gallium arsenide MMIC LNAs mounted into cavities in the parent assembly, hooked up with bond wires, and then a Southwest Microwave edge clamp mount connector is also included into the design. We're going to simulate this from DC to 26 gigahertz over 53 frequency points. And in this case, instead of using our internal Keysight cluster, we're going to use the Nimbix cluster. So now the Nimbix services provide many more design resources to the engineer. So instead of running it on 4 parallel nodes, we're going to run this on 8 parallel nodes because we have that availability through Nimbix. So here's what the design looks like. Actually, let me show this to you live. Let me go back to screen share mode here. Share. Okay, we're looking at the ADS layout of this design. You can see it's a little switched module here. So there's 2 RF inputs, this RFin 1 and this RFin 2. If I switch to 3D mode here, you can see this coplanar launches into these gallium arsenide devices that are mounted down into a cavity that's cut out into the board. And we're hooked up with these bond wire interconnects. So the 2 switch paths combine into this BGA switch here. We go out through a power amplifier module. And finally, we have an EMPRO 3D model for this Southwest Microwave test connector. Once we launch this in RF Pro, the entire design comes in this 3D mode here. And what you'll notice is this interface looks very similar to the EMPRO interface. So once you know one of our interfaces, there's nothing to learn with our other tools. So SI Pro, PI Pro, EM Pro, RF Pro all share common interfaces. So now that we have this design and ready for simulation in RF Pro, we'll go back into our simulation options. So here we're going to go from 0 to 26 gigahertz. Now when I go into resources here, right now under this host field, I'm pointing off to the Nimbix simulation service. You can see my status indicator has gone green. If I choose this little icon right here, what's going to come up is what Stephen was describing before, is this simulation service dashboard. So this is going to show all the designs that I have currently running on the service. Right now I'm not running anything, so this is blank. So I'm back into RF Pro. I'm just going to specify the number of parallel frequency points I want to run, and I'm going to launch the simulation. You can see I've run previous benchmarks on this. The new simulation that I'm running here is now kicked off right here. And what I really like about this whole solution is I can stay resident on my high-performance Windows laptop with my Windows ease of use and my high-performance graphics card to be able to, render complex assemblies like this without having to window into remote desktop window into remote machines. I find this very useful. I can just launch a simulation and have it go off into a high-performance Linux cluster. So now if I go back into my simulation service here and my dashboard and I press refresh, you can see the design has started simulating. And if I go into the actual Nimbix Jarvis platform, you can see what's coming up here is you can see all the different computing resources that the design is using to compute. So if you just noticed, right, it just launched this 128 gig machine right here. It's starting to do the processing on this. As the simulation moves forward, you're going to see more and more resources popping up here. You can monitor how much CPU, how much memory you're using on each of these resources. Okay, let me stop sharing here and go back here.
Yep, back to slides now.
Thank you. Okay, so we've run the same benchmarks on this design that we did on the previous job. So again, on my local i9 laptop, this took about 3 hours. On a single HPC node from Nimbix, about an hour, 15 minutes. And then parsing this out to 8 parallel frequency nodes, we've gotten an 83% reduction in simulation time. Okay, that's all I've got. Thank you very much. I'm going to hand the presentation over to Mike at Nimbix.
Thank you very much, Dan. Greetings, everyone. This is Mike Schutz with Nimbix, and I'm joined by my colleague, Adil Nawar. So, guys, what we want to do is just provide a little insight into who Nimbix is, a little brief overview. We've been in business for about 11 years. We started out with a focus trying to put accelerated computing into the hands of users. And this was primarily in the beginning with the use of FPGAs and GPUs. And one of the focuses that we've always had is to make the use of this technology in cloud computing as easy as possible. We eventually developed our platform called Jarvis, and we'll refer to that in some different ways through the presentation today. Jarvis is the operating system. It's where everything goes. It's where you ultimately start to do your work. We're currently supporting countries in 74 countries across the globe. And we're engaged in a collaboration with Riken for some cloud enablement of Fugaku, which is considered the world's #1 supercomputer. And we're trusted by many Fortune 500 companies, including world-class partners like Keysight. So there's 3 main offerings that Nimbix has. The first is our cloud, which is accessible from any device, which we will show you. And it was the world's first supercomputing and cloud offering. We also have Jarvis XE, which is a wonderful tool that enables people to work in multi-cloud, to manage clusters. It's both a management and an orchestration tool to handle all HPC functions, no matter where they exist. It is a cloud-agnostic platform as well. And then we also have HyperHub, which allows you to curate, run, and update all of your applications, both in-house or provided from other software partners like Keysight. So from there, I'm going to kind of hand it over to my colleague, Adil. And Adil, the floor is yours, sir.
Sounds good. Thank you, Mike. So as Mike was mentioning, the real goal here of Nimbix is to make cloud computing as easy as possible. And one of the really nice things that Nimbix provides is that HyperHub utility where anytime Keysight updates their applications, the next revision comes out, it'll automatically populate and get deployed inside of JXE. So it's really an amazing utility. So here's a couple of verticals that Nimbix focuses in. Obviously, we are an HPC provider, so we focus on all these different verticals. Our main focus is simulation. So that's where about 60% of our customers focus. You can see that we do kind of cover the basics here. The first and foremost thing about Nimbix is the fact that it is extremely easy. Users can come in and they can start a cluster in just a matter of 5 clicks. We do support a variety of different hardware. So we've got 16 core machines, 20 core machines, and you can set up on any hardware. So that's really the beauty of what Nimbix can provide. Obviously, data security is important to everybody. We do work with a lot of different items like ITAR and GovCloud, air-gapped environments, things like that are all supported. We do support the 3 things that, as Mike described, multi-cloud, hybrid, and on-prem, and that's where JXE can come in and deploy and provide you this unique environment where you can run locally on your machines and then burst to the cloud as well. Another really nice thing about Nimbix is that we do have quite a few built-in project management tools where you can control your team, share data, set up environments and limits to users, things like that. And then it also has a project management built-in tool there that I'll show here in just a second. And as I mentioned, the latest and greatest will always be updated when vendors like Keysight update their applications. So I'm jumping over to our platform here. Give it a few seconds for it to update. So our platform actually utilizes any web browser. So you can open up Chrome or Firefox, Internet Explorer, go to platform.jarvis.com. And once we set up an account for you, you log in and land on our dashboard page. And this will show you if you have any jobs running. It also has your project management tool here on the left. It also has your total runtime and cost numbers down here in the corner. So very transparent, very easy and simple layout. And as I mentioned, the goal here is to make it easy to use. So what you do is you simply click on this compute button. You can go ahead and type in Keysight and it pulls up the Keysight applications. My first click, I'm just going to go ahead and click on ADS because that's what I want to run. It shows you what you're going to run. My second click, I'm going to run in desktop mode. So I go ahead and click that. And this is where I build my cluster. I can look at the different machine types that we have. So for instance, let's say I want to run on this massive 20-core, 384 gig machine. I can go ahead and simply do that. And all I have to do is simply click submit. So that's click number 5. And Jarvis, the tool that we've created, is actually going to our data center right now live. It's grabbing that machine. It's starting that machine for you. So it is dedicated. It is yours to keep until you're done. If I had picked multiple machines, you would see, instead of 1 node, you'd see like 5 nodes or 10 nodes. It's really that simple. There's a lot of items going on under the hood here that are building the application, deploying it, distributing it across the variable machines for you. And you can see here, I did have a couple of other sessions already open. So you do have the ability to run multiple sessions at the same time. And now that this is open, all I do is I simply click on this preview screen here, and it pops open a new tab in my browser, and I am actually controlling that machine live in my browser. So for those 7% that actually said they're using their child's Chromebook, you can actually run this on a Chromebook. You really don't need a powerful computer. You can run this on a tablet. I'm actually running it on my little laptop, which is a 4-core laptop. Hardly any RAM on it, but I'm running this very powerful machine that's got 16 cores, 128 gigs, and I can run through these simulations extremely quickly. That, I'm going to jump back to our slide here. And I'm going to go ahead and turn it back over to Stephen so he can go ahead and take it from there.
Yeah, thank you very much, Adil. That's great. And I really appreciate the partnership that we've had, and also, as a user of your platform, I'm actually really happy. It's very easy to use, so thank you. All right, so I'm going to bring us home now, and I'm going to provide a last case study. This is another signal integrity case study. It's another DDR bus, but it's on a different board. And this DDR bus this time is a little bit different because we did the command address lines. We did all of the command address and control lines. And so that means that 48 signal nets in total, 100 ports. But what I did on this is I chose to scale the hardware. So I ran the simulation with a single Nimbix machine and then compared to ×4, ×8, and ×12 to kind of show you how you can bring the simulation down, simulation time down by scaling up the hardware resources. So this is how it turned out. So 3 hours on a single machine, which actually is pretty good considering the number of frequency points, the number of ports that we have. And then we were able to bring it down just under an hour, and then coming up to 8 or 12 machines, we were able to bring it down to just under half an hour, which was excellent. And the use model for me is exactly the same, whether I'm running a single or 12 machines. I'm just specifying in ADS how many machines I want, and then the Design Cloud Sim service is actually starting the machines on Nimbix on demand. All right, so we're going to conclude things now, and just wanted to kind of remind you that we've introduced new simple HPC licensing. These are EM licenses for HPC that can be used for any type of EM simulation. So it could be for speeding up RF Pro simulations with Momentum or FEM, or SI Pro, and in the near future for PI Pro as well. It enables you to be able to get better utilization of HPC assets you may already have. So many of our customers say, yeah, the other design group does have a cluster. It's very hard for me to get time on that cluster or to, organize the IT to do it. This can give you a very easy access to be able to send your simulations off and make use of what you have already. We also now, with our partners Nimbix, have excellent cloud scaling for peak demand. It's very, very easy to use. And not only that, we do have dynamic enterprise agreements. So you have the ability for your larger enterprise to start to put in HPC licenses and increase those to kind of match your simulation needs as you grow. So altogether, we think that Cloud HPC enables a predictive, productive design cycle. And finally, we'll come to our last slide, which is just to say, so how did we do? Do you feel that now you have the ability, have enough knowledge to answer these things? What is HPC? Why is it important? How can it be deployed for me? How did we use it in ADS? And how can I access the Nimbix platform? Okay, and so with that, we're going to move into a Q&A session, but I'll pass back to Carmina to lead us through it. Thank you, Carmina.
Here's one. What do you mean by Design Cloud starts cloud the Nimbix machines?
Yeah, sure. I'll take that one. So, yeah, that's something we were very, very excited about with the Nimbix platform is that our Design Cloud Sim service, you started on a very small machine on Nimbix, so just a really small machine. It's just a web service. And then Dan puts the address, the IP address of that web service into ADS, and when you press simulate, it sends the job to the Design Cloud Sim service running on that very small machine on Nimbix. And then this is the beauty of it. The Design Cloud Sim service starts machines as necessary. So if you'd asked for 8 machines of a certain type, certain size, when it comes to the processing of the parallel solve, it will go and start 8 machines and start loading them with work. So yeah, it's dynamic and scalable in that sense. It just makes things really simple and easy from the user's perspective. And also, those machines shut down when the job's done.
Great. Here's a question from Dennis, and this will probably be for Mike or Adil. Can you run Jarvis Nimbix on any device?
Yes, you can work from any device.
Yes, that's really the beauty of Nimbix, is where you can actually open up the platform from any web browser. So as long as you have the internet access, you can open it up from your cell phone, tablet, and access through your browser these applications, and then open up those applications and work with them interactively. So it does give you the ability to not only monitor, but do the simulation live through your browser.
Great, thanks. And you know, Adil's video was working this entire time, and then right when, for some reason it's not working, but he does have a very nice face, so thank you, Adil, for hanging in with us. Here's a question from Bert. Do you need a local copy of the ADS license, or can you do everything on the cloud on a pay-per-use model?
Yeah, I'll take that, the first part of that, and it's to say from the Keysight perspective. At the moment, we don't offer a software as a service, use model for ADS. But what they do, do very regularly is the Nimbix hardware, and it will have a secure connection, secure tunnel. To your company's license server. So they're using your company's, ADS licenses in order to run your simulations. And obviously that license, the tunnel is just for those machines that you've started, obviously. So it's very secure.
So here's a question from David, and this may be for our folks at Nimbix. How do I ensure IP control security of data after the solution?
So I'll go ahead and take that one. So we've got a variety of different security utilities available. So we do provide the ability to transfer data that is encrypted. We have vaults that are also encrypted. And then we do have the ability to, our data center here in Dallas, that one is ITAR registered and certified. So we are SSA and SOC 2 certified. But the nice option about JXC is that you can actually deploy that anywhere. So you can deploy it internally on your own cluster. You can deploy it on GovCloud if you've got some secure work or something that's secret or top secret, then you need to have that sort of environment. And then this JXC utility actually has been deployed and tested on air-gapped environments as well. So again, depending on what level of security you need, we can definitely work with you on that.
Great. Thanks, Adil. Here's a question from Soren. Do all ADS simulators support this cloud submissions of simulations, or only EM simulations?
Yeah, I'll take that one. So for our circuit simulators, and there's many circuit simulators that individuals, especially in RF domain, would like to speed up significantly. Yes, we can parallelize those simulations, but it doesn't have exactly the same use model. This new design cloud use model is only for the EM simulators in RF Pro, EM Pro, SI Pro, etc. But for sure, it's on our roadmap to extend this nice use model, directly to circuit simulation in the near future. But yeah, if you want to do parallel sims for circuit, you can do that today. It's just a different use model.
Great, thanks. Here's a question from Lenny. I think we can answer this one. Does the software optimize the number of cores and nodes used in simulations, or does the user need to manually select the number of nodes or cores?
Yeah, that's a good question. So at the outset, the more cores that you have available, the better the multi-threading that's capable. So you will definitely see a significant speed up from going from a 6-core engineering laptop to a dedicated 16-core machine. There's no need to restrict the threads on that, and especially in the case of usage on Nimbix. No, you'll use the entire machine for that job. And then when it comes to number of nodes, that really is up to the designer's choice. And there's you will get, as you see with the simulation time versus scaling, there's definitely some trade-offs in, how much hardware do I want to be using versus what kind of speed up am I getting. So you need to, weigh those up. But for sure, in my own experience, just going to ×4 simulation is a significant, speed up. So yeah, I'd suggest just to try it out. It'd be very easy to get going with Nimbix, and we can provide some evaluation licenses for you if you want to test it out.
Great, thanks. Here's a question from David. Do we need an NDA to use the ITAR simulations?
From the Nimbix side, and if you want an NDA, that's your choice. It is not something that we require, but we are definitely welcome to cover yourselves to execute one with you.
Great, thanks, Mike. And then, Stephen, there was a number of questions that you answered in the chat so you saved yourself some time, because I know, folks, if you have more questions, you can ask them now, and the team will respond. If we run out of time, they will respond by email. But, Stephen, what were some of the questions that folks were asking?
Yes, and so there was questions about pay-per-use model. I think we kind of covered that we offer time-based licenses, so you can do 12 months license, but we don't offer pay-per-use for the software presently. Some of the other ones were, let me just scan through. This is a good one, which was, what if you use adaptive frequency, sweeps? Because that is something that RF designers are very used to doing. He's using the adaptive frequency sweep. The way adaptive frequency sweeps work is they try to look for resonances, and therefore they're trying to minimize the number of frequency points you need to use, but still capture everything. All the resonances you might expect in, the frequency domain S parameters. AFS does work with parallel simulation, but definitely we see better speed up if you're using a linear sweep. Definitely you see better speed up if you're simulating the types of designs that have a lot of frequency points to solve, and each frequency point takes, a reasonable amount of time, like 5 minutes or more per frequency point. If you've got designs that fall into that category, then definitely you're going to see improvements with parallel sim. One more thing about memory, perhaps. There's many questions about, well, how much memory do I need? It varies depending upon the different jobs and solutions. Some of the big antenna arrays can get up to 200 gigabytes of RAM required. For SI simulations, rarely see above 120 gigabytes nowadays, because of the way that we split some of the domain up to solve. So it's we've got some intelligence in our solvers that bring that memory requirement down. But irrespective, just having a 16-core machine to yourself will give you very significant benefit over just your local laptop.
Stephen, can I just add something on the adaptive frequency question?
Yeah, please.
Yeah, so I actually have the second case study that I presented. I actually benchmarked that also with adaptive frequency sweep. It does do very well. The algorithm with adaptive frequency sweep, I think it took about 50 minutes or so for that design to complete. The thing with adaptive frequency sweeps is there's a little bit of extra overhead with the way the solution is presented to the solvers. So if you say have 8 nodes that you want to parallelize it out over, the way the algorithm is working is it's going to first submit eight frequencies to the cluster. And it's going to wait for all those 8 frequencies to be calculated before it submits the next 8 frequencies. Now, if you have a very well-balanced cluster and all those 8 frequencies finish up at about the same time, then you're sort of maximizing your simulation efficiency. But if you're waiting for just one of those frequency points to finish, it's going to wait until it submits the next 8 frequency points. So there is a little bit more overhead in terms of adaptive frequency algorithm with cluster computing as opposed to doing linear frequency sweeps.
Okay. Thanks, Dan. So thanks again for attending Simulate More, Wait Less. Cloud HPC for PathWave ADS 2021 is here. Brought to you by Keysight and Nimbix. Please visit us at www.keysight.com/find/events for a list of upcoming events. Thanks very much and have a great day, everyone. Be well, stay well, take care.